Solve trigonometric equations that are quadratic in form. What we want to do is solve a trigonometric equation, but the form is going to be a quadratic. Well, first thing we have to do is recognize we have a quadratic form. And quadratic forms are basically in the form of ax squared plus bx plus c equals 0, where that leading term does exist. A is not 0. How do you know you have a quadratic form? This 2 right here. So these quadratic forms can be kind of disguised. In other words, I can go ahead and have a quadratic form that looks like 2x squared minus 7x equals negative 3. So that if I set this equation to 0, I'd be able to see the quadratic form more clearly. I could even disguise it better. I can factor out an x and have 2x minus 7 as the other factor. This is equal to negative 3. And I'd have to realize this is a quadratic form because if I distributed the x, that 2x squared is still the leading term. I could still set the equation to 0. And if we do have equations in quadratic form, what can we do? Well, we can solve by what? We can solve by factoring, completing the square, even the quadratic formula, but we have to remember we're solving for the trig function, and we still have to solve for the variable after that. So the way we do this is we go ahead and say to ourselves, if we're going to solve a trig equation in quadratic form, verify 2 is the largest exponent on the trig functions. And if any trig function is raised to the power of 1, we'll write the equation in terms of that function. Otherwise, just kind of skip this step. Then you're going to make a substitution. You're going to let u equal that trig function. You'll write the equation in terms of u, and this will give you a quadratic equation, and then you solve it with factoring, completing the square, or the quadratic formula. And what you've solved for is the trig function. Well, that's no good. I need to solve for the variable. So then I'll go ahead and set that trig function equal to u and go back and solve for x. What does this all look like? Well, what this looks like is I give you a equation. Notice I want to solve it on 0 is less than or equal to x, which is less than 2 pi. So the first thing I do is I just verify that I really do have a equation in quadratic form, which I do. And that tells me I need to begin the problem, so I'll make a substitution. I look here, and I'll let u equal the sine of x. So when I rewrite this equation, I have 2u squared minus 7u plus 3. And that's equal to 0. This I can solve, and hopefully by factoring. Does it factor? Oh no. Tell me if it factors. If I set up my parentheses, I'll do the easy part. The first terms are both obvious, 2u and u. The rest, not so obvious. Does this factor?
It does.
What does it factor to be?
It factors to 2u minus 1.
Good.
Times u minus 3.
Beautiful. Now I'll just set each factor to 0 and solve, but I won't be done. But let's set each factor to 0 and solve. 2u minus 1 is 0. Or u minus 3 is 0. So if I solve for u, what are the two values of u? U is what? U is
1/2.
Okay, or what? Or u is what? U is?
Or u is 3.
3. Now I want to solve for the variable what? I want to solve for the variable
X.
and I solve for the variable u. So I have to keep going. Now I go back and say, let's see. I know that u is equal to what? U is equal to the?
To the sine of x.
So I'll replace u with the sine of x. Now I have the sine of x is equal to 1/2. Or the sine of x is equal to what? It's equal to?
To 3.
To 3. Now if the sine of x is equal to 1/2, and if I'm solving on 0 to 2 pi, I have to realize that I can be in two quadrants. A smart trig class. Sine is positive in the first quadrant and the second quadrant. So in the first quadrant, if the sine of x is 1/2, what's x equal to?
Would it be pi over 6?
Very good. That's one answer. That's from quadrant 1. From quadrant 2, I'm going to go ahead and say, gosh, x would be equal to, now if my reference angle is pi over 6, what would be that rotation all the way over to it? It would be
That would be 5 pi over 6.
Very good. And if that's not completely evident, all you're doing is taking 6 pi over 6, which is the rotation of pi, and coming back pi over 6 units. I assume that's what you did.
That is what I did.
Now, for the other factor, the sine of x equals 3. But think about the sine function. That's the y-coordinates on the unit circle. Sine, those y-coordinates go from -1 to what? To
1.
To 1. So this is not possible. So it looks like I have how many solutions? I have
You have 2 solutions.
2 solutions. How are we doing so far?
Doing great.
Now we can check these, I suppose. If you wanted to check it with a graphing calculator, graph the function on 0 to 2 pi. And notice we ended up with 2 solutions. It's often hard to predict the number of solutions. So to see if you have all the solutions, graph the function on 0 to 2 pi, and then maybe choose to count the tick marks by pi over 6. And you should see 2 horizontal intercepts, one at pi over 6 and one at 5 pi over 6. Thank you, and thank you.